This problem has a different pattern than what we've seen before. The first two terms have a common factor of tangent x, but if all of the terms don't have a common factor, then common factor won't help us because a combination of factors and terms is not helpful. But you should notice that this term is squared, this term is a variable, but it's to the first power, and then this is a constant. And hopefully that reminds you of an algebraic pattern of, say, x squared plus x minus 2 equals 0. And if we were finding the solutions for that, then we would factor it, if possible, into two binomial expressions. So we're going to do the same thing with our tangents. Instead of x, we're going to have tangent x. There's only one way to get tangent squared x, and that's tangent x times tangent x. There's only one way to get 2, which is 2 times 1. Now I need to subtract the factors of 2 and the tangent squared to get a positive tangent x in the middle. So I need a plus on the 2 tangent x and a minus on the 1 tangent x. If I combine those, then I get a positive tangent x in the middle. Very important, of course, to factor that correctly, or nothing else you do is going to get you the right answer, except maybe graphing, which would not be legal. So now I have two factors equal to 0, which means that either the first factor is equal to 0 and or the second factor is equal to 0. If I solve this first factor equal to 0, I'm going to subtract 2 from both sides. So I get tangent x is equal to negative 2. Remember that tangent can have any value, so although negative 2 is not a special value for tangent, it does have an angle that gives it that value. So we're going to have to use the calculator to find that because it's not special. We'll do that in just a moment. Let's go to our other equation over here and let's solve this one for tangent as well. Tangent x is equal to 1. Now 1 is a special value for tangent, so we can use our hand trick to find these x's right here. Notice that the 1 is positive, and between 0 and 2 pi, the tangent is going to be positive in quadrant 1, and it's going to be positive again in quadrant 3. So I need two answers from this little equation right here. If you use your hand trick in reverse, then you see that tangent equal to 1 happens when the angle is 45 degrees, which is your reference angle in quadrant 1. And in quadrant 3, if you have a reference angle of 45 degrees, then you have an angle of 180 plus 45, which is 225. Now I've just made a mistake because these angles need to be in radians because our output limitations right here are in radians. But 45 degrees is the same thing as pi over 4. And then this reference angle is pi over 4. Remember that if you're at pi, that's 4 pi over 4. You add one more pi over 4 and you're at 5 pi over 4. So really easy to work with the radians here. Now let's go back to this other little equation over here. And we want to know where tangent is equal to negative 2. Well, before we go to the calculator to find that, we can mark where we know our answers are going to be. Somewhere in quadrant 2 because tangent is negative in quadrant 2. And somewhere in quadrant 4 because tangent is also negative in quadrant 4. So now we're ready to go to the calculator and figure out what our angle values are. Notice that we need to be in radian mode for that. I'm going to add a calculator page here, and I want to make sure that I check my settings, and my angle is in radians on this page, and that's what I want. Now to ask the calculator where is tangent equal to negative 2, the only way I can do that, other than graphing, is to use the tangent inverse. So tangent inverse says where is tangent equal to, and then the argument is going to be negative 2. Remember that the calculator is only seeing this much of it, and so it's giving you an answer that is based on that side bubble that arctangent has answers in, from negative pi over 2 to pi over 2, so this side bubble. And this negative angle that you get as a result is in quadrant 4. Now let's take this information back to our paper. We know that negative 1.1072 is in the negative direction. Keep in mind our answers have to be between 0 and 2 pi, and there are no negative numbers between 0 and 2 pi. So this is the answer that the calculator gave me. It's not one of my answers, but it gives me enough information to figure out what my answer should be. I want an answer that's coterminal with this. I want an angle that's coterminal. So I'm going to add 2 pi to it to get this positive angle that still ends in quadrant 4 at the same place. Now the question is, how far is it from this angle to this angle right here? The reference angle here is 1.1072. And so I'm going to have the same reference angle right here. If I take 180 and I subtract 1.1072, then that's going to give me the angle. What that means is that from this angle to this angle is 180 degrees, or it's pi. From here to here is pi. So I can find this angle on the way to finding the coterminal angle to this. I can take this result from my calculator, add pi to get this angle, add pi again to get the positive angle here. So here's what that looks like. I can add pi, and then if I just press enter again, then it's going to take that answer and add pi again. So 2.0344 is the quadrant 2 angle, and 5.1760 is the quadrant 4 angle. So to write my angles, my solutions to this, I get x is equal to, and then I list those 4 out. If you can give those angles exactly, like 5 pi over 4 and pi over 4, then you need to give them exactly. But if you don't have a special value, then you don't have any other choice than to give the radian measure, which doesn't always have pi in it. So that decimal, and then also the 5.1760. And remember, the negative angle that your calculator gave you was just information for you to use. It's not one of your answers.